Okay, for this kind of problem here, I'm going to ask you different questions like, what is the amplitude? What is the amplitude? What is the number of cycles? What is the starting? Okay, I could ask you anything. What is the displacement? Okay, so if I ask you any of those, usually you're going to have to define a function. So if you look at this function right here starts at 0, so c is 0, right? And it ends at what? At not 2 pi, because 2 pi is right there. It doesn't end right there. It ends right here, right? So it's from 0 to 2.5 pi, okay? So since it's 0 to 2.5 pi, that's my period length. My p-value is 2.5 pi, which is what? Same thing as 5 pi over 2. Okay? So now, we're going to use that to find out what B is. But look at this. Your displacement here is 0 because it's in the center, and it's got the amplitude of 2 both directions, right? So, and it's a cosine, it's a positive cosine, so it's a positive 2 right there. So if I ask for the amplitude, you're going to give me 2. If I ask you for the displacement, you're going to give me 0 there. If I ask you for the B value, you're going to have to enter that in the formula. B is equal to 2 pi divided by P. Now, the reason you're going to have to do that is because we're dealing with radians. We're not dealing with degrees, so it's 2 pi that we're going to use. Okay? So we're going to enter 2 pi, and we'll do this, divided by 5 pi over 2. Why did I do it this way? Because someone have something divided by a fraction, so it'd be a little bit easier to see it. So how do we do this? We can multiply by just flipping the fraction here. So we get 5 pi, 2 over 5 pi. There's a 1 here. Now we can reduce it. The pi's cancel out, and B, it becomes 4 over 5. So my B value is 4 over 5 up here. Okay? Now, is it different than what we've been doing? I've been showing you only one cycle. Now they're showing you more than one. Capture your graph and answer. Okay? And I usually cater to the ones that are closer to 0. So let's go back over here. Let's go to this one over here. This one again is going to be cosine. But what's the deal with this one here? What's the deal with this one here? The deal with this one is it ends at where? See, it's more than, it ends at where? 5 pi, right? There it is. There's my cosine. You got to identify that. So it's cosine that we're looking at. The A value doesn't look like it's 1. It's what? It looks like it's 3/4, right? See that? See the way this is about 3/4? It's in between half and 1. So every unit is going up by a half. You see that? So that's like 0.75 or 3/4. And then we'll ask for the B value, the C value, and the D value. The D value is still 0 because it alternates over and under from there. And it goes 3/4 above it, 3/4 below it. You see that? Now the C value is 0 as well. Here, if I ask for the B value, I know that the P is equal to 5 pi And so I know that b is equal to 2 pi divided by, yeah, it's 2 over 5, right? Because the pi's cancel out. This one I can enter it this way so I can see it easier. And there it is, 2/5. 2 over 5 is my b value there for that one. Okay? So I can ask you any of those 4 questions for these kind of problems. What about that one there? That one's, here I would say, I can ask you for the cosine of it or the sine of it. In this case, I probably would say the sine. What is the sine? What is the period length of the sine? Well, the period length, so if I ask for P or if I ask for B, I can ask for any of the 4. But for my sine, if I ask for the sine one, it starts here and it ends there. So that means that it's 1 over what? 1 over 72. So P is 1 over 72. So B is P, sorry. B is 2 pi divided by B. So you multiply, so you change this to 72 over 1. That's the same thing as 2 pi over 1. So that's going to be 1, what is that, 144? So that's my b value right there, 144 pi. Now, what about the amplitude? The amplitude is 4. It goes 4 up and 4 down. And my sinusoidal, my d value is 0. Right? So we're able to write the equation on this. Okay? So here I'm giving you in radians. These values could also be in degrees. So look out for some of the ones that I've given you before. So if I've given you one like this. And if this is 80 degrees, and I give you this one as 100 degrees. Can you write the equation of this? First of all, what you need to understand is, how much did I give you? Did I give you the full amount, or did I give you half of the amount in terms of the period length? See, I gave you enough information to write the equation. So my full length would be from here to there, from minimum to minimum. You see that? But I don't know what this value is. But I do know what this displacement is. What is this? What's the difference between 100 and 80? 20. 20 degrees right there. So now, again, we're dealing with degrees now. We're not dealing with radians, so when we find B, we're going to use 360 over pi, right? I mean, 360 over P. So now, what's my full length? What's my full length of the cycle, which is called P? 40, right? Because I gave you half, this marker to that marker, from maximum to a minimum, that's half amount. So you want to know the full length? Double it. Okay? So P is 40. What's this value right there? 7 plus 1 is 8. 8 divided by 2 is 4. That value is called your what? D value, right? And what's my A value? 7 minus 4 is 3, right? That's your A value. And this is going to give you your B value by doing 360 divided by 40. The zeros cancel. 4 goes into 36 how many times? 9. Okay? So you got A, B, I need C. C is this one right here. If I know that this is 20, yeah, so I need to backtrack 20 less than 80, and that's going to be 60. And that's the value of the C. So now, what about A though? Look at the A. We said it was 3, but really it's going to end up being what? Negative 3 because of the shape of the cosine. It's a negative cosine, so that makes that one negative. Okay? Because for it to be positive, it will have to start at the top for the cosine. So my equation is y is equal to negative 3 cosine of 9 theta minus 60 degrees plus 4. Okay? So that's what you're going to need to see as well, to be able to see that. Now, what if they try to trick you and give you values like, let's see, we have something like this. Okay, notice that they don't have degrees on them, right? And if I show you something like this, let's see, 4. Okay, so what if I ask you for the b value here? So what is the b value? Okay, what do we do here? We concentrate on one of the functions. Either we concentrate on this one here, one of the cycles, right? Or this one here. Let's concentrate on this one here. What is my length of that from here to here? What's the length from there to there? Right? So P is equal to 16. So what does that tell me? It's not in degrees, right? We don't see the little circle right there, so it's not in degrees. So I need to use B is equal to 2 pi over what? 16. So what's my answer? Pi over 8. Pi over 8 is my answer. You see that? So that's my period length. Now let's keep on going. What if they wanted us to write the negative sign of this? So they would want us to, if they say the negative sign, we would want this. We would want this here. Right? So if we want that there, if they say negative sign, you can write it by, let's see, we go to y equal, A is 4, but it's a negative sign, so it's a negative 4. B is pi over 8. And I don't have to surround the x by parentheses because my d value is 0, and then I can say, and then also my c and my d values are 0, right? So that's my equation right there. This test is mainly about you understanding what they're asking here. If I give you a function, one thing that I want to show you is that if I give you a storyline and I end up saying this cosine of and this describes some information, okay? And whatever storyline this is, they want to know the period. So they say, what is the period? Well, notice that this is not in degrees, so it's in radian. So the formula for a period is the reverse of what we did for B, right? 2 pi.
Do you know Elizabeth Medellin?
Yes, I do.
Can you bring somebody to attendance for a few minutes?
Okay. So we got 2 pi over b. So I know what b is. B is this one here. So I don't need to know the storylines to find the period length of whatever they're talking about. I just need to know what b is. So that's going to be 2 pi over 1/3, but I can write it like this. 2 pi divided by 1/3. I flip the divisor to make it 3 over 1, right? So 6 pi is my period length. Now, what if they want it in terms of a unit like hours or seconds? So they want to know how. See, 6 pi describes whatever they're talking about. So if this t is in hours, right? Then all you have to do is multiply 6 pi in the calculator, and that's going to be equal to what? Go ahead and enter 6 pi in the calculator. What do you get? Anybody? 18.84. So that this, whatever they're talking about, one cycle to repeat itself, it takes 18 hours, 18.8 hours, close to 19 hours. Okay? So whatever they're talking about. Okay? One other thing that I want to go over is I'm going to give you a storyline about a Ferris wheel. Okay? And let's go to one of those problems here. Let's see. Let me see if I have one. Ferris wheel. Well, let's go to this one. Let's do the one that we had on this assignment here. We'll almost give you the answers. Let me increase this. Okay. So we look at this Ferris wheel right here. I'm going to look at that. I'm going to see that. Hold on. So let's see. Here it says a Ferris wheel is 25 meters in diameter. So there's a Ferris wheel that looks like this, right? The diameter is, from there to there, is 25 meters. From there to there. Okay? And it says, from a platform that is 1 meters off the ground. So there's a platform here that it's standing on, right? I guess for people to get on there and walk on there. To get on there, there's the stairways or steps. And this is 1 meter. This is 25 meters. Now, how do I find some of the values here? Before I even read too much, how do I find some of the values with this information here? Well, let's see. This here right here is going to be my d value, which is my sinusoidal. sinusoidal axis, okay? And this is where it's going to alternate. The person that's going to be writing this is going to be going as low as 1 meter and as high as how much? What's the height here? 26. And this is 1. So what's between 26 and 1? 26 plus 1 is 27. 27 divided by 2 is what? What is 27 divided by 2? It's in the calculator. Huh? 13 point what? 13.5. You see that? So, that's my D value. My sinusoidal axis is D. So D is equal to 13.5. My amplitude is what? The difference between 26 and 13.5. What is that? What is it? 12.5. Okay. Now, if we try to graph this and try to understand what happens, in the beginning, at time 0, the person is 1 foot off the ground, right? It starts getting on, starts going higher and higher, and then they come down. Okay, this value right here is your 26 height. This value here is 1. Right in the middle is your 13.5, right? And so it's going to touch ground somewhere at this location. And if we read this, it says one full revolution is 10 minutes. So that's 10 minutes right there. It takes 10 minutes to do the complete thing. And this is usually maybe when it's loading. Maybe this is the cycle when it's loading, or maybe it's a big Ferris wheel where it moves really slow. There are some Ferris wheels like that are really, really big, and they move real slow. So maybe the time is a little bit exaggerated, but in our case, we stick to this information, and we know that is from 0 to 10. So that's my p-value. My p-value is 10, so that makes my p-value be 2 pi over 10, right? Which is pi over 5. Okay? So that brings in the equation. C would be 0 because, look, it starts at 0 time, right? So our equation will be right there. Y is equal to what? Now, is it 12.5 or negative 12.5? It's negative. Look, the cosine is a negative cosine. So it's negative 12.5, right? Cosine of pi over 5. And then we got x. We don't have to put x around parentheses because it's 0 for d. So x, and there's a displacement of what? Of 13.5. That's my equation there. With this information, you should be good for tomorrow. Let me show you one more. Okay. What if you have something with more than this? What if these cycles are supposed to be the same, right? Pretend that they're the same length, right? And we have a graph right here. And we'll say that it cuts it up right there. And then what if I gave you this value right here? And I tell you that it's 6 pi over 5. So now, how do we find, what if I want to find the period? What's the period length? We know that from 0, this is 0 right there, 0 to 6 pi over 5, how many cycles are in that location? So you got to look at this and say, okay, they look like negative cosines here, right? There's 1, right? And then there's another one right there. So how many cycles is that? From 0 to 6 pi over 5? 2. So what's half of 6? So I need to divide that length by 2. So on your calculator, you can do that. You can do 6 over 5 divided by 2 and press enter and go math 1. But then you can re-enter the pi. So here I'm going to do this. Divide this by 2. Now if there's 3 cycles, you divide it by 3. So that changes to multiplication. So that's going to be 1 over 2. And that's going to be 6 pi over 5. The 2 and the 3 cancel out. I mean, the 2 and the 6 cancel out, making the 6 to a 3. And that's 3 pi over 5. That's the length of one cycle of this graph here. So from there, that value right there, it's 3 pi over 5. And that's the period length. Now, there's so many cycles there, but I only want to look at the period of one cycle. That's what they're asking for. Do you understand that?